Dear student, in this lecture we are going to discuss about the JJ Thomson atomic model. JJ Thomson proposed his atomic model in 1897. In order to understand JJ Thomson atomic model, it is very important to understand the previously available atomic models. It was John Dalton who proposed his atomic theory in 1803. And according to John Dalton, a matter is made up of a tiny individual particle. Matter is made up of tiny individual particles known as an atom. Atoms are indivisible and cannot be created or destroyed. According to John Dalton, all same types of element, all same elements are made up of same types of atoms. The fourth postulate of Dalton atomic model was that compounds are formed when different elements combine in different ratio. So these are the four basic postulates of Dalton atomic theory. According to Dalton atomic theory, matter is made up of tiny individual particle, and that particle is known as an atom. So the atom, according to John Dalton, is indivisible small particle, and it cannot be created and destroyed. According to John Dalton, all same types of elements are made up of same types of atom. That is the reason. That's why we can see same kind of elements. According to Dalton, the compounds we see in our daily lives are made up of different elements, and these elements combine in a different ratio, and due to difference in ratio of different elements we can see different kinds of compounds. So this was all about the matter, that the smallest particle up till 1897 it was believed that atom is the smallest particle, and scientific community also believe on the Dalton atomic theory. However, in 1897 JJ Thomson discovered a new particle, uh, and it is known as an electron. And Thomson proposed his own atomic model on the basis of discovery of electron. Thomson said that there is not an atom which we say as the smallest particle. There are also other particles such as an electron and they are negatively charged, they are present inside the atom. So this was an advancement to the Dalton atomic theory. So now, dear student, let us discuss that the the JJ Thomson atomic model and what were the basic postulates of the JJ Thomson atomic model. JJ Thomson in 1897 proposed that an atom is a not smallest particle, and he said that consist of atom consist of subatomic particle or atoms contains charged subatomic particles known as electrons. These subatomic particles which are present in an atom are negatively charged, okay? They are negatively charged. The second postulate of JJ Thomson was that atom have electrons and these electrons are embedded inside atom like a plums in a pudding. So these were the two basic postulates of JJ Thomson atomic model. JJ Thomson atomic model is also known as JJ Thomson Plum pudding model. So according to this model, atom is not atom is divisible. An atom consists of subatomic particles. These subatomic particles are negatively charged and they are known as electrons. Atoms have electrons, but these electrons are negatively charged and they are embedded in atom like a plum in a pudding. JJ Thomson also proposed that a charge on an atom is as a whole neutral, but the the positive charge is distributed over the whole surface of the atom. And these charges are balanced out by negatively charged electrons which are embedded like a plums inside the atom. So we can explain the JJ Thomson atomic model with few examples. So dear student, according to JJ Thomson, atom is just like a sphere and the positive charges are distributed over the whole sphere. So the positive charge is wholly or uniformly distributed over the whole atom. Whereas according to JJ Thomson, the electrons which are negatively charged are embedded into the positively charged atom, and due to this positive and negative charge they cancel out their charges, and due to this whole atom is neutral. We can explain a JJ Thomson plum pudding model with an example of a daily life like a watermelon, where the red part is just, we can say, it's imaginary representation of a positive charge, and whereas the seeds which are embedded inside the watermelon, they act like negative charges, and both the positive and negative charges cancel out the whole effect, and due to this the whole atom will be neutral. Now, the student question here is that how the new charge particles were discovered by JJ Thomson. JJ Thomson performed an experiment, and on the basis of experimental observation, JJ Thomson discovered newly negative charge particle known as an electrons. JJ Thomson performed cathode rays tube experiment, and on the basis of cathode rays tube experiment, he concluded that atom is not the smallest particle. There are few other particles which are negatively charged, and they are known as an electron. They are also present inside the atom. So now, dear student, let us discuss that how JJ Thomson discovered electrons. JJ Thomson gave his Thomson atomic law or plum pudding law based on experimental observation by performing cathode rays tube experiment. On the basis of cathode rays tube experiment, JJ Thomson concluded that an atom also consists of other particles, and these particles are charged. These particles are negatively charged, and they are known as electrons. The experiment performed by JJ Thomson is known as JJ Thomson cathode rays tube experiment. Dear student, cathode rays tube is basically a glass tube. It is a vacuum glass tube which is evacuated. The glass tube is evacuated by a vacuum pump. The pressure inside the glass tube is around 10 raised to power minus 4 atmos or 0.001 torr. So the pressure inside the vacuum tube or glass tube of the cathode rays tube is very low. The glass tube consists of a metal plate which is known as cathode, whereas the other metal plate which is present in a cathode rays tube is known as anode. Now question here is that why these two metal plates are known as cathode and anode. Basically, cathode plate of a cathode rays tube is connected with a negative terminal of the battery. So cathode is a type of electrode which push electron from itself, or which give electron out from itself, whereas the anode of the glass tube is connected with positive terminal of the battery like this. So the role of the anode is just to push the electron, where just to pull the electron, and whereas the role of the cathode is to give or to push the electron inside the cathode rays tube. So both the electrode and cathode are connected with negative and positive terminal of the battery. Cathode rays tube is also coated with a screen which is known as fluorescence screen. The reason of coating a cathode rays tube with a fluorescence screen is just to observe if any kind of rays are produced inside the cathode rays tube, where they just interact with the fluorescent screen and we can see a glow. So on the basis of that, we can have an observation that there are radiation produced inside the cathode rays tube. Okay, so the negative terminal of the battery basically causes the flow of the current through it, and it will go toward the cathode, whereas the positive terminal of battery is connected with anode of the cathode rays tube. So electron will be pulled by the anode, and whereas positive charge will go toward the cathode. So the positive and negative terminal of the battery will cause a potential difference between the cathode and anode of the cathode rays tube. So due to the potential difference, high potential difference, it will cause the emission of the radiations, and these radiations are known as cathode rays. The student, please keep in mind that the potential difference between positive and negative terminal of the battery is somewhere around 10 kilovolt to 50 kilovolt. So very high potential difference will be used in order to generate cathode rays in a cathode rays tube. So the cathode rays, when they are generated inside the cathode rays tube, they interact with a fluorescent screen. And when they interact with a fluorescent screen, you can see a bright spots of a fluorescence inside the cathode rays tube. Now, interesting question here is that which JJ Thomson observed, that what is the nature of these cathode rays which are produced in cathode rays tube. What could be a possible charge on the cathode rays, whether they are negatively charged or positively charged, or they are neutral. So that was very interesting point. In order to confirm the nature of the cathode rays, JJ Thomson performed another experiment. So this when JJ Thomson again take a cathode rays tube and performed a cathode rays tube experiment again, but there were slight modification in a cathode rays tube experiment performed this time by JJ Thomson. The student, the general construction of cathode ray tube was same, like it has just a glassed vacuum tube. It is connected with pump, and it has a cathode which were and another metal of an anode. Both these cathode and anode were connected with negative and positive terminal of the high voltage battery. So now JJ Thomson just slightly modified this setup. This was a fluorescence screen. In modification of JJ Thomson experiment, JJ Thomson basically took two metallic charge plates. These metallic charge plates, uh, he basically charged them with positive, and you connect them with positive and negative terminal of the battery. So due to connection of the plates with positive and negative terminal of the battery, these charge plates were basically charged with positive and negative charges like this. So the additional plates which JJ Thomson used was positively and negatively charged. So now, when the high potential difference is created between cathode and anode of the cathode rays tube, it will cause a generation of cathode rays. Now, interesting question here is that JJ Thomson observed that when an additional uh, charge plate were introduced in a cathode rays tube, the cathode rays start to deflect toward the positive charge plate, and you can see a fluorescence, just deflection in a fluorescence screen. This indicates that, as you know, that positively charged particle attract the negative charged particle, whereas the negative charge particles deflect the negative charge particles. So the same kind of charges deflect each other, whereas opposite kind of charges attract each other. This means that the cathode rays, they are basically spiralate, they are basically deflected toward the positive charge plate, indicate that the cathode rays are negatively charged. So these rays, he called that these rays are based on electrons, and he called that the cathode rays are basically or consist of a beam, and that beam is known as electron beam. Now here is very interesting question, students. In order to confirm the nature of cathode rays, JJ Thomson performed slightly more modified his experiment. As you know that a moving charge particle has, if a magnetic field is applied on a moving charge particle, magnetic charge particle, the charge particle will basically deflect with a magnetic field. As you know that the famous Lorentz equation, that F force on charge particle is basically in a magnetic field is equal to q e plus q v cross b. This means that the magnetic field is always perpendicular to the direction of the flow, perpendicular to the velocity of the charged particle. So this means that when suppose these are two kinds of magnet, like these are have a north and south pole, they have north and south pole, okay. So the magnetic field of lines basically moves from north pole toward the south pole. If the charged particle like electron E move perpendicular to the north and south pole of the magnet, the electron will start to spiralate like this. So this means that if JJ Thomson said that if the if the cathode rays has any kind of charge, then these rays, when he will apply a magnetic pole like this, north, suppose this is the north pole and north pole of the magnet, and suppose this is a south pole of the magnet. So he said that when he will apply a magnetic field uh, inside the cathode rays tube, then if these rays, the cathode rays, if these rays have a charge, then these rays will interact with the magnetic field, and due to spiration there will be a deflection in an opposite direction. And JJ Thomson observed that when JJ Thomson applied these magnetic poles inside the cathode ray tube, he observed that the cathode rays basically they start to deflect toward the opposite direction of the fluorescent screen like this. This was the deflection of the cathode rays. On the basis of both the on the basis of both uh, the both observation like the application of the charge plate and a magnetic field, JJ Thomson concluded that the cathode rays are basically are based on negatively charged particle, and these negatively charged particles are known as electrons. So now, students, let us conclude the JJ Thomson cathode ray tube experiment. JJ Thomson cathode in JJ Thomson cathode ray tube experiment, JJ Thomson basically verified the presence of an electron inside the atom. For this, JJ Thomson took cathode ray tube. Cathode ray tube has a cathode and anode metal. Both the cathode and anode metals are connected with negative and positive terminal of the battery. When the electric potential is applied across the anode and cathode of the cathode ray tube, if there is a high potential difference and cathode ray tube is fully evacuated, then there will be a production of cathode rays. The nature of cathode rays were confirmed by applying two different metallic plate electrodes, and these were charged with positive and negative. These were positively and negatively charged by connecting the metallic plate with potential battery. He observed that when the metallic plates were connected with a battery and when they are charged, the cathode rays start to deflect toward the positive charge, which means that two opposite charges attract each other. This concludes that cathode rays has a negative charge. They are based on electron. Furthermore, in order to confirm the nature of the cathode rays, JJ Thomson took magnets, and he observed that if there is a charge on the cathode rays, these rays must be deflected in opposite direction. He observed that when we applied a north and south pole, put north and south pole of magnet inside the cathode ray tube, he observed the deflection of the cathode rays on the opposite direction. On the basis of that, JJ Thomson concluded that the cathode rays are based on negatively charged particles, and these negatively charged particles are electrons. So on the basis of cathode rays tube experiment, JJ Thomson validated his atomic model. As you know that the JJ Thomson atomic model says that the atom is not the smallest particle of a matter. There are other negatively charged particles present inside the atom. They are embedded inside the atom like a plums in a pudding, whereas an atom acts as a whole, has a positive charge which are distributed uniformly over the whole surface of an atom. So the negative charge and positive charge of atom counter down each other or balance their charging, and on the basis of that atom is neutral. So dear student, this is all about the JJ Thomson discovery of electron and JJ Thomson Plum pudding model. So thank you for watching this lecture.